LeetCode Problem 1448. Count good nodes in binary tree. So this problem gives us a binary tree and a node x, right? And basically what it wants us to do is to count how many nodes, right? How many nodes to x that have no, there are no nodes value with a value greater than x, right? So for example, for tree, right? So tree, so this is the root node is always a good node because tree is not more than 3, right? 3 is 3, so this is a good node. Okay, to 1, so from 3 here to 1 is already 1 is considered a bad node, right? Because in order for 1 to be a good node, the node before it must be smaller than 1. So in this case, since it's 3, this is 1, so this is a bad node. For this 3, it's the same thing as our root because our root was 3. So the biggest nodes from root to this node is 3, which is the same as its value, so it is a good node. So this node is good, right? So for example, this one, right, since 4 is bigger than 3, this is a good node also. This is a bad node because 4 or 3 are bigger than 1. And this is a good node because the numbers from root to node 5 is all smaller than node 5. Okay, we have the same example here. Alright, so this is a pretty simple solution I have, which is using DFS. Right, so what I'm doing is I am traversing through the nodes depth of search while keeping the maximum value in mind, right on the path. So right, for this instance, if I'm here, so if I were to come here, I'll know that my max is 3, right? And when I come here, my max will still be 3 because it did not update here. Whereas if I come here, my max was 3, and since this is 4, so my max now turns to 4, right? Then I check again, I check here again. So if this was to be 3, it will still be a bad node, right? Because 4 is bigger than 3. Okay, so here in the function, I have a count here. So this count is what I'm going to return. I'm referencing it, right? So depth of search the root, starting from the root, and then the root's value will be the max, the current maximum, which is currently 3, and the count, which is currently 0. So I'll write it down. So count will be global here. Okay, and then root is 3, max is 3, right? So since root is not null, we don't do anything. And if the value of the root is more than or equals to max, which in this case it is, because 3 is equals to 3, so max will stay the same as 3, but count will increment, so we have 1. Then we depth of search to the left, DFS left. I'll open up like this to indicate this is a recursion, right? So the root now is the left node, so we are going to the left side, so the root is now 1. Max is still 3, right? Because max did not change. The count is still 1, right? The count I'll just leave it here because since we're referencing it, it will always stay the same. Okay, if root equals to null, it's not. Root value is smaller than max, so we don't need to update max, we don't need to increment max. So we DFS left again. Now our root is 3, max is 3, right? So we are going over here. Then since root is equals to max, it is, so our count increments 2, max updates to itself, DFS to the left again, right? In this case, now we are DFSing to a null node, right? Since it's null, we just return, right? So this DFS will just close. Same with the right node, right? This is a null, you just return, right? And then our DFS here is done, right? Since it's done here, so we can close this, and then we DFS all this. Actually, I'll leave it open here. Yeah, and then we DFS to the right. We write the root. We are back to here, and on the right node is null again, right? So the right node will just instantly return now, right? So DFS right closes. So we are done with this. So now we are DFSing the right for the root node, right? So we're going back to where we came from, is 3, and we're going to the right side now. Okay, I won't delete it, right? So the root is now 4 over here. It's now 4. Sorry, it should be empty. This one is now 4. The max is now 3, right? 3. Okay, root is not null. The root's value is more than max, right? It is 4 is more than 3. So our max have to update. It will now be 4, and our count will increment, so to 3. Then we DFS to the left again, right? There's the left side first, so we're going to the left. So we're going to this one here. The root is now 1, max is now 4. Since the root value is smaller than max, we don't need to do anything here. The left node is null, right node is null, so we go back to 4, right? So we go back to 4, so the DFS right. Okay, on the right node, so here now, last node, the root is 5, right? 5, the max is 4, right? 4. Okay, since the root is bigger than our max again, so our max have to update to 5, and our count we need to increment, so count increment like this. Okay, and then again it goes to the left node, goes to the right node. Since they're both null, you just close, this one will close, right? Then we are back at the root, so we are going backwards back to the root, and then once we are done, this function exits and we just return the count. In this case, the count is 4, right? Remove everything, yeah, the output is 4, which is correct. Okay, pretty simple depth search. Hopefully I've explained well enough. That's all I have to show. Thanks.